Hello students, welcome to the Yupp Master Foundation program. Today we are going to deal the very important topic related to the conversion of units in different systems for the 9th class students. Okay. So, while you are going to take that entrance examinations, there is a one question which is related to this conversion of units. One physical quantity can be expressed in different system of units. You need to convert from one system to another system. You have taken that one physical quantity, how it is going to be converted, let us see. Yeah, the concept is conversion of physical quantities in different system of units, all right. That is what, if we are going to take that one system, how it is going to be converted, let us discuss. Yeah, you have taken, so for that system 1 in first system and second system, just we have to take that. Now, you are going to express that value in terms of fundamental quantities, the mass, length, time or the fundamental quantities. Let us see that mass, length. Generally you are going to take that any derived quantity that can be expressed as m l t power some a b c, all right. It is going to be expressed in terms of this one. So, we are going to consider that value of that derived quantity is going to be n1 in the first case, that is n2 into m. Yeah, I have to take that in the first system, you can take a b c, all right. You are going to take that L1, second system you have to take that T2, this is a, b and c. Simply the powers are going to be raised, all right, to express the derived quantity in terms of the basic fundamental quantities m, l, t. It is going to be very clear. I will give the example, just if you wants to represent that force, it depends on mass and acceleration, just you have to take this mass and acceleration. We have to take that mass in terms of n, acceleration is in terms of L and t. Just the powers are going to be 1, 1 and minus 2. If you are going to take that t, its power is going to be minus 2, all right. If you are getting this expression, you can express that force in different systems, that is in terms of SI system Newton. If you are going to take that CJ system, yeah, for this force you have that SI system and CGS system, you will take that Newton, you will take that dyne. So, the value can be expressed in Newton, in terms of Newton or in terms of dyne. So, you know very well about that 1 Newton is equal to 10 to the power of 5 dyne, all right. This is the case we can convert from one system of units into the another system, right. You want to find out that if they have given that value in one system, you need to find out that value it is going to be find out in another system. It is easy. How it is going to be calculated? Just we have to write down, that is m1, just you have to take that, yeah, L1 by L2, T1 by T2 power c, that you have to get this one. It is very clear, we are going to express that one system of units into another system of units, you can take that, right. So, N2 is the value of the derived quantity in the new system or in the second system. If you know the value of one derived quantity in one system of units, you can convert into another system also, but if you know the relation, this is very important. Very simply, just we are going to talk about that. Yeah, if you know that this relation, you can express that force in newtons into dynes also. So, you will convert that force which was expressed in terms of the newtons, it may be in dynes also. That is the conversion of 1 Newton into dyne. Easily you will get that 10 to the power of 5. Already we have discussed in the previous classes. Now, we are going to accept that new kind of the problems which are frequently asked in the entrance examinations. Let us have that look, right. Okay, we need to raise, all right. Yeah, we would like to accept that problem, that is, in a new set of units, unit of mass is 10 kg, all right, unit of length is 1 kilometer and unit of time is 1 minute, all right, it is given, right. Now, the value of 1 joule in this hypothetical system, we are going to be hypothetical system means theoretical, hypothetical means which is theoretical opinion, theoretically it is correct, according to someone's opinion it is going to be correct. Hypothetical means somebody is having that, in the view of someone it is opinion, it is correct. Practically it has been proved, then only it is going to be stated as a statement or law or whatever. Okay, let us talk about that another one, right. That is a new system of units they have given, all right. Now, while you are talking about that value of 1 joule, all right, 1 joule you have to get that. Yeah, first of all you need to get that joule is the derived unit for energy, it represents energy in a energy, all right, all right, it represents the energy. Okay. In SI system, let us assume you have to get that the value of joule in another system, if they have given that mass, length, time. Yeah, you know that 1 joule is equal to 1 Newton meter, all right, it is very clear. Simply it is going to be identified, that is, you can get this 1 Newton here, that is 1 kg meter second square into meter. So, you are going to get that 1 kg meter square second power 8, this is about 1 joule. Yeah, this is the expression that we are having. It has been represented with the powers of the base quantities, that is, you will take that m power 1, L power 2, T power minus 2, all right. So, the value of 1 joule in a generalized system, that is 1 J is equal to N1 into this one. So, you can take that this is the generalized representation for 1 joule, but what they are asking you, they have taken if mass is equal to 10 kg, all right, length is 1 kilometer all right. Time is 60 seconds, I hope so. They have given 1 minute, all right, just you have to take this one. All right, time is equal to 1 minute. So, this is the case which has been represented in one case, just we have taken it in the first system. What is that value? Its value is going to be 1 joule, its value is going to be m2 into m2 power 1 L2 power 2 T2 power minus 2. This is the case we are going to take that. This is the first system, we have taken that suffix is 1. So, you have to get this value, you have to express that value, all right. It is going to be taken, right. Shall we go for the problem solvation to have the answer? New units. Okay, let us go for that problem, all right. We would like to erase this part. Oh, it is clear. Now, you are going to take this. Yeah, we have to solve this problem by getting the relation. Okay. So, in first system, yeah, in first system it is going to be, just you can take that direct relation, it is better. Yeah, it is 1 kg. Generally, this is the general representation. General representation. We would like to take this one, all right. Right, we have to take that general representation. After that, we will follow for new one, that is new hypothetical system, right. That is 1 kg meter per second square. In hypothetical system, we would like to take this one, that is 10 kg, and they have given 1 kilometer and 1 minute. This is the case what they have given. What is the value of that joule in this hypothetical system? In general representation, that 1 joule is going to be equal to meter, yeah, 1 joule is equal to 1 Newton meter. This is the case we are having. Here also we can take this one. Let us go for this one, right. We will solve the problem by generalized relation, that is N1 into M1 power A, L1 power B, T1 power C is equal to N2 into M2 power A, all right, L2 power B, T2 power C. While you are going to take that 1 joule, it is going to be M power 1, L power 2, T power minus 2. It is very clear, we are going to know about this one. So, your aim is going to be N2. So, therefore, N2 is equal to, here it is going to be 1 joule, here N1 is 1 joule. In N2 system, what about that? It is the question mark. You are going to take that N1 and N2, they are the values, just you have to get that value. right. You will find out that, yeah, you will take that. Here what about A is equal to 1, B is equal to 2, C is equal to minus 2. It is very clear. We are going to take this value for A 1, B 2, C minus 2. We are all going to take this one. It is very clear we are going to know about these powers. They are raised to a particular value, whether it is positive or negative, we have to see that, right. Easily we can solve the problem by the substitution. You can take that, that is m1 by m2, here it is equal to 1 joule, right. We can get this. Power 2 L1 by L2 power it is going to be 1, it is going to be 2 T1 by T2 whole power minus 2. It is very clear we are going to get this one, but it is in, yeah, you have to take that M1 is equal to 1 kg. Yeah, L1 is equal to 1 meter, T1 is equal to 1 second we are taken. But in the given problem this is 10 kg and 1 kilometer and 1 minute, and you can take that M2 is equal to 10 kg, L2 is equal to 10 kilometer, T2 is equal to 1 minute. It is very clear, just you have to substitute and get the value. You have to take this one, right. Therefore, N2 value can be obtained, that is 1 kg by 10 kg. We have taken this, and what about L1? 1 meter by 1 kilometer, T2 1 second by 1 minute power minus 2, and just you can convert this numerator or denominator getting that unique Q system. Yeah, of course they are going to be having that same value, but here you have to get that conversion, that is kilometers to meters, right. You will get this one 1 by 10, here it is going to be power is 2, 1 by 10 power 3, yes, meter kg, just we have to write once, power 2, that is 1 by 60 second by second, just we have taken power minus 2. All right, that value is going to be 1 by 10 power 1, 1 by 10 cube power 2, 1 by 60 power minus 2. It is very clear we are going to get this value, please wait. Now therefore, N2 is equal to 1 by 10 power 7 into 1 by 3600 whole power minus 2. Okay. Now it is going to be taken as 1 by 10 to the power of 7 into, sorry, yes, we have to get that final expression, it is very easy. So finally we are going to get this one 3600 by 10 to the power of 7. So you can take that 3.6 into 10 to the power of 3 by 10 to the power of 7 you will get that 3.6 into 10 to the power of minus 4 in new units. This is the way we are going to convert. Yes, in this way if you are approaching to convert any derived quantity value from one system to another system. Here they have taken in 1 joule and they are going to be taken, mass is going to be 10 kg and length is going to be 1 kilometer and time is going to be 1 minute. This is for hypothetical system. In this hypothetical system it is going to be calculated that 1 joule is equal to 3.6 into 10 to the power of minus 7 units. Right, you have to get this one. Right. In this way we can solve the problem. Right. But while you have to solve the problem, you need to know about this one. This is the representation. How you have been obtained? 1 joule is equal to 1 Newton meter. So, if you are going to take that 1 Newton 1 kg meter per second square, and finally you have been obtained that value. Okay, let us go for another one. Yeah, power can be expressed as, it is very clear. Okay, let us see. If you are going to take that power rate of doing work, just we are going to talk about that power, it is very clear, W by T. All right. Now, you are going to get this work time, let us assume work done by time. Okay. Now, if you are going to take that power is equal to force into displacement by time. Yeah, we are going to know about this one. So, you can express F into T, sorry, F into S by T. Simply you are going to get that F into S by T. You have to write in terms of this one, just you have to write this one. So, you know very well about that displacement by time, it is going to be velocity. All right students, just you have to get this one S by T. So, finally, you are going to be getting that it is going to be F v. Let us see the answer. Yeah, it is going to be, yeah, F dot v, just you have to take that. These are all the vector quantities. So, you are going to represent F bar, S bar. So, finally, you will get that F bar and T bar, okay, because force is a vector quantity. Yeah, displacement is also vector quantity, is a vector quantity which has the direction. If you are going to take that one physical quantity which is following the direction, it is known as vector quantity. All right, displacement is going to be vector quantity. Right. So, F is going to be represented bar, S bar, we are going to take that. Yeah. So, the first one is the correct answer, you have to do that. You have been obtained that final expression, the power can be expressed as F bar dot P bar. It is going to be taking. In this way we can solve the problem, it is not a big task, it is going to be bar V bar, this is power, right. Right. So, let us go for another one. Yeah, these are the matrix match type questions, you can see that. Here we are going to take that angstrom, mile and light year one born, right. If you are going to take that microscopic parameter, you have to take that. The microscopic parameters are going to be estimated in terms of angstrom units, in terms of Fermi, in terms of Born. What are the microscopic particles? Just we have to see that. This is clear. We are going to take this one, right. If you are identifying that, this is the atom, right. This is the orbit. We are going to take that. This is the nucleus, just we have to see. This is the nucleus. We are going to take this one. Right. This is the orbit. This is R. R is the radius of orbit. Or simply, if you are going to take that the radius of atom, it nearly represents the size of, it is going to be expressed the size of atom. Okay, our aim is to consider the microscopic parameters, radius of the orbit. Let us assume this is going to be nucleus. So, the radius of atom, it is going to be expressed as in terms of angstrom units, expressed in angstrom units. It is very clear. So, it is going to be little bit small, right, as compared to the radius of the nucleus. Okay. You can take that. Now, you are going to take the use of angstrom to represent the radius of the orbit. Let us assume in case of hydrogen atom, we would like to represent the radius of the atom is approximately equal to the size of the atom. Just you have to take that, it is one electron is going to be revolving. Okay, all right. 1 angstrom is equal to 10 to the power of minus 10 meter. Is it clear the purpose of the angstrom units to represent the radius of atom or any microscopic parameter? All right. Right. So, in the given question it is there, 1 angstrom is equal to 10 to the power of minus 10 meter over, right. Now, you are going to take that, this is the nucleus, yeah, you are going to get that cross section, just we have to get that nucleus. The cross section area it can be measured in terms of Born. So, 1 Born is equal to, in order to represent that 1 Born, all right. Are you getting the use of the Born? 10 to the power of minus 28 meter square, very clear, all right. That is what you are going to get, that the microscopic parameters are very useful to describe that the structure of atom, and size of atom, radius of the atom, about that nucleus, you are going to get into the nucleus, it is very good, it is very small, and apart from you are having that radius of the nucleus, again you will take that radius of the nucleus. It is going to be 1 Fermi, it is a 10 to the power of minus 13 centimeter, we would like to take this one. Yeah, we are going to take this one Fermi, just we have to take, it is the additional information you need to know that. Already we have discussed about that, yes, all right, it is very clear. The remaining two parameters are useful to express the distance travelled by the body. The distance travelled by the body can be represented in terms of miles or kilometers, but in case of that light year, the distance travelled by the light is going to be 9.46 into 10 to the power of 15 meter, approximately it is going to be 9.5 into 10 to the power of 12 kilometer in a year. The distance travelled by the light in a year, it has been represented in terms of light year, it is very clear. We are going to take that mile, it is the unit to represent the distance. If you are going to take that, 1 mile is equal to 1609 meter. If you want to express in kilometers, it is going to be 1.6 kilometer. If you are going to take this value, all right. So, please note this one, this is also important. Yeah, 1 mile is going to be 1609 meter, approximately it is going to be 1.6 kilometer. All right, this is the case we are going to discuss. All right, we have discussed about that light. Right, if you take that some part, yeah, light year, we have to take this one. So, distance travelled by the light, yeah, we are going to take that, that is 9.46 into 10 to the power of 15 meter, just we have taken. It has been approximated as 9.5 into 10 power 15 meter, and it is going to be given in, yeah, this is the right, we are going to get this one. All right, we have learned that additional information regarding to that microscopic parameters and also macroscopic parameters. So, the distance travelled by that one object, it is going to be macroscopic. Just it is very clear, it is also that from that nucleus we are going to take that distance to the orbit. It is very clear, it is also distance, but that it is in microscopic view. Light year and mile, they are going to be related to the macroscopic. So, they are all about to represent that distance between the 2 points or two any reference points. All right, we are going to discuss radius of the atom and radius of the nucleus. Fermi, it is going to be used to represent the radius of atom in terms of Fermi. Radius of the nucleus, radius of atom is in terms of angstrom units, nucleus cross section area of that regarding to the nucleons. Very simply you are going to talk about that size of the nucleons also, they are going to be in that area, that cross sectional area has been identified, it is very clear. It is going to be extended to the microscopic particles inside that nucleus, that is one bond, it is going to be related to the nucleons. Again we are going to into nucleons, all right. So, let us go for another one. Yeah, it is a simple, these are all the integer type of the questions they are going to ask in the IIT mains level and some other competitive examinations also. If you are going to represent that, yeah, 1 micrometer, that is value is going to be 10 to the power of minus 6. So, okay, right, it is going to be taken 10 power minus 6 meter. If you are going to take that, it has given that angstrom units also. Yes, you need to take that 10 power minus, yeah, you have to take that minus 6 and then 1 angstrom is going to be 10 power minus 10. They have given that 10 to the power of 16 meter, and then you are going to represent 10 to the power of 1 angstrom is also there, that is 10 to the power of minus 6. So, you need to get that x value is going to be minus 6, okay, you will get that, all right. Just if you are going to represent that x value in terms of that power, so they have given 1 micrometer, you have to get that final answer, that is 1 micrometer is going to be yeah, you can take that, it has been taken 10 power x angstrom units, right. Okay, if you are going to take that 10 power x into 10 to the power of minus 10 meter. So, you have to take that 10 power just you can, if you wants to express this value, you have to get that 10 to the power of minus 6. Generally, if you are going to take that 10 to the power of minus 6 meter, right. If you are going to take that 1 angstrom, it is going to be converted into 10 to the power of minus 10 meter. So, finally, in that place of x you have to get that 10 to the power of minus 16, it is very clear, you can solve the problem. Again you can take that 1 nanometer is equal to 10 power minus x, you know 1 nanometer it is going to be 10 to the power of minus 9 meter, that 10 to the power of minus x meter. So, x is going to be 9, right, you can take this one. Okay students, thank you very much, have a nice day. We would like to discuss the more number of problems in the coming classes also.